make sure you can hear my voice for the explanation. Alright, try to increase the size here so that it's more clear. Alright, uh, so from the notes, look at the notes again, look at the notes. Alright, here the note says for to find lateral force, okay, to find lateral force Fy, you need slip angle. Slip angle here is alpha. Alpha start from negative 20 degrees until 20 degrees. So in our model, okay, make sure you can see. All right. We use input alpha as a RAM here, RAM. Slope is 1. Initial output is 20. 20 negative 20 p means negative 20 angle here. Negative 20 is initial output from the RAM, negative 20. Okay, and then 20 is the final input for the model. Okay, so from negative 20 until 20, you need 40 40 data, 40 times lah. So since our model start from time equal to 0, start time 1, so you need to put until 40 here. So from t equal to 1 until t equal to 40. Okay, t equal to 40. So 40 data. Okay, 40 data. T1 is for alpha negative 20 degrees. Alpha negative 19 degrees. And so on and so forth. Alright. And then the first block is for 2 kilonewton. So the next block, next we apply 4 kilonewton. 4 kilonewton. Just put number 4. And then next one is 6. 6 kilonewton, just apply 6. And then 8, okay, just change to 8. Okay, so we have 2 here, 2, and then 4, we have 4, 6, here we have 6, and 8 kilonewton, 8 kilonewton. So we need to analyze at 4 different loads, vertical load. Alright. Okay. So connect to the FZ, and then alpha, same alpha, from negative 20 to 20 degrees. Alright, so okay, so we need the same alpha for each blocks, and then when we want to compare, use marks. Commonly use block, use marks. Compare in one graph. Change the number input to 4. Okay. Alright. Copy, no need to copy dah. Same scope. Alright. Input, output Fy, and then Fy. Don't forget to run the parameters first. Run the parameters all. All the parameters run beforehand. Okay, and then run the simulation until the sound thing. You hear the something, and then see, this is the result. So we follow the one from the books. Okay. So from this result, you can see that okay, we can get the same pattern. For example, the green line here, this shape, green line is equal to Fz 8 kilo Newton. Okay, and then red line here, this red line is the not this one. I think this is the green line. Is it? Uh, Confused. Wait. Okay. Okay. So this yellow line, the first yellow line is the load 2 kilo Newton Fz. Then you can discuss. Discuss. Make sure when you want to discuss, pick a very significant point or line. For example, at 10 degree angle of alpha, or 15, or 20, or -10, -15, or -20. It's easy for you to discuss, to describe or explain the performance of lateral tire force. For example, at 10 degree of alpha, slip angle 10 degree, this line, when you increase Fz, you increase the value of Fz. So increase here from blue line to green to red, and then to light blue. So the lateral force also increase. Okay, Fy. Okay, very easy to discuss. As long as you get the right um, graph. Okay. Uh, okay. Right. And then maybe when you do simulation, you don't know which line is which. So you have to label. Sorry, all right. In your test this Friday, you have to produce the graph. The graph. For example, this graph. So how you can use this graph? So how can you use this graph? Okay, just print screen. Wait. Wait. So you just get this graph and print screen. For me, I use snipping tool. Snipping tool. I always use snipping tool. Where is it? Alright. So select this graph. This is your result. And then you copy this graph and put in your words file. For your test, you have to put the graph. This graph here, or the one you can produce in using plot function. In the book, we have learned a little about plotting the graph using command line. And then you discuss.